Welcome back. We've got our data plane prepared. We have talked about data processing units and smart NICs and all that kind of stuff. We've got our managers deployed. We've covered a whole lot of ground so far. Now we're starting a whole new topic here. We're getting into NSX logical switching, and we're going to break logical switching up into a few different pieces. We'll talk about those in a second. Now, why do we need to talk about logical switching? Well, because this is an opportunity for us to change how we deal with layer 2 networking in our virtual infrastructures here. We need to think about overlay networking and tunneling and all these different things that we're starting to get into. Now, we're going to go through an overview logical switching here, right? That's this first video is about an overview of the logical switching architecture. Why are we doing logical switching? What's the value of logical switching? All that kind of stuff. Then we're going to go into segments. We're going to start talking about how to configure them. We're going to talk about how to configure segment profiles and how we're going to do packet forwarding, right? How the packets move through this logically switched network. And so that's kind of a run through of what it is we're going to talk about. Now, this is just going to focus in on the logical switching architecture, like I just said. The other topics, those are going to come in some additional videos here real soon, so be patient with me. But here we're going to talk about NSX segments, what they are, why they are, what we're going to use to do our overlay networking, the Geneve protocol there, what we're going to do to actually program this, what are some of the different components involved. And so we talk about logical switching, and we talk about doing all this logical switching, and we're not just creating these logical layer 2 domains for no good reason. Why we're doing this is ultimately because over time, virtualization has done some very interesting things to networking in general. And really, when it comes down to it, layer 2 networking has some challenges that we have to find ways to overcome in this modern data center environment, right? That's just really what it boils down to. And so we're using logical switching to further enable multi-tenancy by being able to provide each tenant their own logical switches. We're trying to affect some scale there, right? Remember, with VLANs, we only have 4,096 of those available. Well, logical switches, we can get many more. So we can crank the scale up quite a bit further with logical switching. We can, with this overlay networking, we can span existing physical layer 2 boundaries. So I can create these logical layer 2 domains and allow virtual machine mobility into far, far more places throughout the data center and even across data centers. So logical switching is actually a really, really valuable tool in our toolbox. Now, what do we need for logical switching to work? Well, we basically need to do everything that we've talked about up to this point. If you're watching all of these videos in order, we need our NSX managers deployed, and we need our ESXi hosts prepared as transport nodes. That's really it. That's really what it boils down to, is we need these basic building blocks in place so that we can start building out logical switches and consuming NSX. We think about logical switches, and we can look here, and you can kind of pause the video and soak in this diagram. But what we're looking at here is the fact that we're creating segments, right? In the policy engine and the policy UI, we're going to create objects called segments. And segments are going to be, these logical layer 2 domains. Think of them loosely, and I mean this very much. Think of them very, very loosely as port groups that we might use on a distributed switch. There's more to them than just a port group. But we can think about that, right? The segment is going to be exposed as a port group on a distributed switch. And we're going to attach virtual machines to that segment. And those virtual machines will ultimately be attached to segment ports. And we can control how the traffic is flowing and what traffic is allowed to flow and some of the behaviors of that virtual switch port, of that segment port, through segment profiles. But those are all policy constructs. If we look at these constructs in Manager, Because remember, we talked about the difference between policy and manager. If we look at these constructs in the manager UI, we're going to look at logical switches and logical switch ports. And those are going to be far more specific things, right? The logical switch is simply the layer 2 domain. The segment is the layer 2 domain and some other configuration detail that we'll look at in future videos. When we think about a segment, at its core, a segment includes a manager logical switch, right? The logical switch is just that logical layer 2 domain delineation. It's very similar to a VLAN in many respects, but it's not a VLAN, right? Let's not confuse that. Every segment is going to be assigned a VNI, or a virtual network identifier, and that VNI is going to allow the system to differentiate between traffic on segment 1 and traffic on segment 2. Now, segments can be VLAN segments. They can be overlay segments. So this is where I said, a segment is similar in some ways to a VLAN. Well, it can actually provide access to a VLAN. We're going to use VLAN-backed segments primarily in our routing, so we'll talk more about those a little bit when we get into logical routing. That's a future video. But most of what we're looking at is going to be an overlay segment. Now, we're going to make that determination when we create the segment. We'll see when we talk about configuring our segments how we can associate a segment with a transport zone, and that transport zone association is going to define whether that segment's going to be a VLAN or an overlay segment. Now, those segments, whether it's a VLAN or an overlay segment, it doesn't matter. That segment will be presented through vCenter as an NSX port group on your distributed switch. Right? And then we're just going to connect containers or virtual machines or what have you to those port groups. Now, we're moving traffic around the NSX infrastructure, around the logical switch infrastructure by way of tunneling. Now, tunneling is simply a means of taking an Ethernet frame and wrapping it up in something else, in our case, a Geneve packet, and moving that outer packet around so that the workloads in question, in our case, virtual machines, don't have any idea that there's something in between communication there. We're going to configure, we already have configured actually, tunnel endpoints on our ESXi hosts. Those tunnel endpoints do the tunneling work for us. They do the encapsulation and de-encapsulation of our overlay packets. And so when a virtual machine on one host needs to talk to a virtual machine on another host, that's going to be tunneled from tunnel endpoint to tunnel endpoint on the hosts to get the Ethernet frame from VM1 over to VM2. Now, we use a protocol here called Geneve to perform that tunneling. And this is an IETF standardized protocol, so it's not anything VMware proprietary here. But what's going to happen is we're going to take that frame from the virtual machine, and the tunnel endpoint will wrap that frame up in a Geneve packet. So there's a Geneve header, and then a UDP header, and an IP header, and an Ethernet header that get tacked on as well. And we're going to send that frame to the destination tunnel endpoint that's servicing the destination MAC address of the inner frame, of the virtual machines frame. That's going to be sent across UDP port 6081. So we look at the Geneve header itself, and we see a number of interesting things here. This is, like I said, a UDP-based protocol, and the VNI of the overlay segment is going to be stamped into the Geneve header so that the tunnel endpoint knows where to hand off the inner frame. Right? We're not changing the frame that the virtual machine sent at all. We're not changing that at all. We're simply adding this header to it and then sending another UDP packet across to the destination tunnel endpoint. So if we look at what's kind of going on here, Virtual Machine 1 wants to talk to Virtual Machine 2. So Virtual Machine 1 is going to send out an Ethernet frame destined for MAC address DEF. And we're going to get that at the virtual switch. and look for that destination MAC address, just like any other switch would do. Where do I need to forward this frame to get it to its destination? And we're going to identify that MAC address DEF actually lives on a different transport node. So we're going to take that Ethernet frame, wrap that up in a Geneve packet. And we can see down at the bottom of this diagram, we can see that we've got the the layer 2 and the IP and the ultimate payload for the frame from the destination, or from rather the source virtual machine. And then before that, we have the Ethernet header, or the Geneve header, I'm sorry, the Geneve header, and then a UDP header, an IP header, and the outer layer 2 header. That's all stamped on by the tunnel endpoint, and we're going to send that Geneve packet from the source tunnel endpoint to the destination tunnel endpoint. When the destination tunnel endpoint receives that Geneve packet, it's going to start peeling off all the headers. It'll get to the Geneve packet. It'll process the information there and say, okay, this layer 2 frame needs to be forwarded to this VNI. And it's going to take that inner layer 2 frame from virtual machine 1, put it on the virtual switch on the destination hypervisor, and the virtual switch will simply forward that layer 2 frame onto the destination virtual machine. VM1 and VM2 have no idea that the frame has been encapsulated and sent from one hypervisor to another. That's outside of what the virtual machines know. So this is kind of invisible, right? The tunneling is invisible to the two virtual machines on the same segment. As far as they know, they're simply connected to the same switch. So we've kind of talked about segments a little bit, what they are, kind of compared and contrasted a little bit between segments in policy and logical switches in Manager, right, at a very high level. We talked about tunneling. We talked about Geneve. We talked about, how tunnel endpoints talk to each other and so on and so forth. Come back in the next video. We'll start talking about how we build these actual segments, how we put this together. And, we'll kind of continue moving forward from there. We'll see you in the next video.